Hey everybody, this is Larry. This is me going with weekly contest 275 Q2. Minimum swaps to group all ones together too. So this one, when I was doing the problem during the contest, admittedly, so I took about 3 minutes. Admittedly, to be honest, I was confused for a little bit, because I thought that a swap is adjacent. And I definitely this was when I realized I have to read the problem a little bit slower, because I definitely missed that for the first minute. And then after that, it just became a more straightforward problem, because you can always swap in and out of things. And the way that I did it with this problem is using a couple of techniques that comes up during competitive programming, but I would say maybe not so important during, okay, by themselves they're pretty okay, but I think it's a little bit awkward for an interviews. I don't know about how much I think about this for interviews, but yeah. But the way that I did it is that, to handle the circular array part, all you have to do, and of course a caveat here is n is 10 to the 5th, so you cannot just do like some n square algorithm where you take every beginning and end point and then just check, right? But the key observation for this problem is that, so let's say for a second, let's say we don't have to care about the circular aspect of this, right? Let's say we're only doing a regular array and you have to group all the ones together. Maybe that's even part one. I don't know. I don't remember these problems per se. And because you could swap everything in, it becomes a sliding window problem. So for example, for something like, let's say this is the input. Maybe I'll take this one actually. Maybe this is a little bit more illustrative. So here, we know that there are 5 ones. That means that in order for them to be together, another way to say that all 5 are together is that we have a window of 5 numbers where they're all ones, right? Because we know how many ones, we could do it by counting, and you could even see a little preview. That's what I did, right? I counted the number of ones. So you know that you have a sliding window of 5 things and they all have to be ones. So then the question is, if you're able to count how many ones there are inside, then you know that everything that's outside, you just swap with the zeros, right? So basically it becomes counting the number of ones in this sliding window, because then here you check, okay, what happens if we put all the ones here, right, in these 5 slots, right? So that's one, and then a second one, you try again here, you try again here, try again here, try again here, right? So in a sense, that's going to be brute force. So in that sense, it's a greedy correct solution, because you're brute forcing every possibility to of putting all the ones in a certain place, right? So this considers it to be so that's my idea for this one, if it was not circular. Because this is circular, there is a trick that you can do, which is that you could do it in a couple of ways. You just have to be really careful. But the way that I did it is still the same idea. Is that sliding window, right? It's just that you have to be a little bit more careful. So now you look at this, 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 and then next you look at this. This, except for that, this thing that extends is to the left, right? And then now you slide again, and then here. Now that those 2 slides off, this slides on, right? And so forth, so dot. There are a couple of ways you can implement this, but even this alone, you should be able to do, even if it's like really edge casey and a little bit weirdness. The way that I did it is just by replicating a second array, like this, and then now it's just the same thing, right? We look at 5 elements, because that's what we had before. Right, so we have these 5 elements, and then we look at these 5 elements, and of course, let's extend one more. But you get the idea, right? Let's just put a thingy here, so that's a little bit easier for me. But yeah, so you look at these 5 elements, you look at these 5 elements, and you look at these 5 elements, and you look at these 5, and that's pretty much it. That's basically the idea. And the number of ways you can do this, you can do it, like I said, with a sliding window. I got a little bit lazy with this actual sliding. Actually, it probably could have been okay, but I was worried about off by 1, so I actually did it with prefix sum. This part is not necessary. It's just a little bit I thought it was easier for me to not make a mistake while programming this during the contest. But you don't actually need this. You just need regular sliding window. And this is a trick to make it easier, is to double the array, so that you kind of do that. And then now, because of using the prefix sums, we can just count like this prefix sum, which I'm not going to go over in this video because, like I said, it's not a core part. But this just pretend that this will give me the number of ones inside inside a window, and we want the max that's inside the window, and then the number of swaps, of course, is just the number of ones inside that max window minus the number of ones that would have to move. So you just subtract it from that. And that's pretty much the answer. This is going to be linear time. The way that I did it is linear space, but you can actually do this in constant space if you're really careful. Without the doubling, for example, and also without the prefix sum, you should be able to do this in linear space. Oh, sorry, constant space, but linear time anyway, because I do it in linear time. So yeah. Let me know what you think. This is only Q2, and it's a lot to explain, but it's actually not that bad once you have done a couple or maybe a lot of these problems. I've done a lot of these problems, so you know, beyond just a couple, to be frank. So, but yeah. Anyway, you could watch me solve this live during the contest next. Okay, that's good. Oh, it's circular. That is the tricky part. How do we do it with more than one window? I mean, it's some sort of greedy, but I'm not really seeing it. So this. Wait, am I confusing the swaps? Oh, oh, wow, I thought it was just adjacent swaps. That's where I messed up on this one. Okay, so it's any swaps. Swaps is such a weird term, I guess. Okay, so then okay, I see. Not this. Oh, this is wrong. This is. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It's a little bit of a redemption round. I mean, I did okay. I think this is around what I'm expected. But yeah, Let me know what you think about this problem explanation. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.